With the new momentum in our trade route from South America to China, cargo ships will now be traveling inland across South America and along the Napa River, through the Andes Mountains, onto the Pacific Ocean, and eventually to China. At the very point in Ecuador where the cargo will be transferred from ship to truck is where Puerto Providencia, a new port city and a gateway into the Amazon, is being proposed. The site is highly nuanced, dynamic, and complex, requiring a flexible design solution that addresses the devastating deforestation of the site, the erratic flooding of the Napa River, the existing agricultural plots, as well as complicated issues of forest management, ecotourism, and cargo logistics. So we started by examining the larger overall site plan and its existing patterns of deforestation. And we noticed a series of existing islands. First, we identified man-made deforested islands, autonomous and disconnected in the middle of the forest. We then discovered a series of forested islands, where virgin forest had been left intact amidst large deforested swaths. Our first step is to reclaim all forested islands, in order to protect the virgin trees and give it back to the forest at large. In order to maximize the land use of the deforested islands, they are reappropriated into ecolodges, agroforestry research farms, storage, and reservoirs. Using these found islands as a design catalyst, we developed a system to make islands. Residential islands across agricultural plots, urban islands at road intersections, and finally Providencia, a large island made up of a series of islands. And all these islands put together results in our overall site plan. Currently, all existing deforested farms are monocultural, so we propose polycultural farms in agroforestry, combining forestry techniques with agricultural technologies to create the most efficient farming conditions. Each plot is divided into steppes of forest, annual crops, perennial crops, and grasslands and wetlands. The stepping provides a temperature difference between the top and bottom tiers, diversifying crop conditions and stabilizing farmers' income. The biggest cause of deforestation is the collateral damage caused by the uncontrolled expansion of roads. So we propose to pinch the ends of all the roads to define a limit to its expansion. Working within the existing transportation framework, roads are demolished and redirected with cul-de-sacs at their ends to prevent further deforestation. Restricted ecological islands hinder the gap crossing ability, area requirements, and migration path for species. Continuous ecological corridors sustain the rainforest biodiversity. Ecological islands are therefore prevented by demolishing roads and replanting forest corridors to allow for a continuous ecological corridor. Sediment sprawl amongst the local inhabitants needs to be restricted into islands of contained density, attracting locals to resettle in small clusters around energy and water sources. Haphazard loss distribution is reorganized so that the number of plots corresponds to the number of sides of each new residential island. With frequent flooding and minimal drinking water, water management is a critical concern. With flooding up to 5 meters high, a series of reservoirs will minimize flooding while providing drinking water for inhabitants. Moats surrounding the stepped agroforestry will collect excess stormwater and irrigate surrounding farms through a series of underground pipes. Using our territorial scale design strategies, we designed Puerto Providencia as an amalgamation of smaller island topologies, carefully building only within the existing deforested pattern on the site. Corresponding to the 19 ecoregions of the Amazonian basin, Puerto Providencia is comprised of 19 distinct islands, each showcasing that region's specific produce. The shape of each island is defined, while the residual space between islands alternates between forest, water, roads, and market squares. In order to prevent any future deforestation, the peripheral limit of each island is controlled and designed, while the inner core is left flexible to densify according to need. Cargo, tourists, and locals all enter the island through distinct ports. An expressway directs cargo straight to the main road, while smaller streets and avenues connect the islands. Providencia has a bus rapid transport system and a sky-high tree bridge that connects all eco-lodges and provides tourists with a bird's-eye view of the rainforest. Bands of program occur along the edges of each island, with strategic openings and entry points. Every island has a market selling the produce of that ecoregion, and creating a shaded informal market square below. Industrial program occurs along the truck routes, and high-rise hotel buildings create a concentrated ring around the tourist port. Storage surrounds the cargo port, as well as creating a hard limit against the forest. Research program, including a school and a University of Indigenous Knowledge, also occurs along the periphery of the forest, so students can research the rainforest and control any future expansion. Providencia is a highly adaptive city and can easily adjust for different future scenarios and conditions.